Hi everyone, I'm Hannah. We're in the topic algebra. We're looking at simultaneous linear equations. This is our third video in this topic, and we are looking at linear models. So linear models are very similar to our other two videos where we looked at the form, gradient intercept form, which is y equals mx plus b. We looked at m as the gradient and b as the y-intercept. And linear models use the same principles, except it is applying this formula to real-life examples. So here it says linear models describe a practical situation mathematically using a linear function. So the best way to understand linear models is to do examples. So we're going to have a look at an example now. So here is a linear model. So as you can see, it uses the top quadrant of a number plane because if we are using real life examples, and just say down here, this is our number plane, and we have negative values like -1. In real life examples, you can't really have like -1 time, or you can't have like negatives of stuff because it's a real life example. So you can only use this top quadrant, which has positive values along the x and positive values along the y. And so that is why linear models will generally only use two values along x and y. So it will just be the top quadrant. So let's read the question and have an understanding of what it's asking. So Grace sells insurance. She earns a base salary and a commission on each new insurance policy she sells. The graph shows Grace's weekly income, I, plotted against the number of new policies, N, she sells in that week. The relationship between I and N is linear. Okay, so here, this is Grace's salary, this is her income, and this is the number of policies that she sells. So as her number of policies that she sells increases, so does the weekly income. So let's have a look at question A, and it says, what is Grace's base salary? So Grace's base salary is going to be the salary she starts with, or the income that she starts with. So if you have a look here, she starts with zero new policies. Her base is going to be $400. So regardless of the policies that she sells in a week, she will get $400 base. So her base salary is $400. What is Grace's salary in a week in which she sells 8 new policies? So it's going to be more than $400 because if you sell more policies, you get more money. So you start with $400 and then you build up. So that's what this sentence here means. A base salary is what you start with, and commission is the extra money you get. So let's have a look at 8 new policies, which is going to be here because new policies along the x-axis. And we go up until we reach the line. We reach the line here if we go across to see how much money she will earn. And so she'll have a salary of $800 if she sells 8 new policies. Question C. How many policies does Grace need to sell to earn $700 for the week? So we're going to go down to where 700 would be, which is about here, give or take. We'll go across until we hit the line. We hit the line here, so we go down and we come to the number 6. So she needs to sell 6 policies to earn $700 for that week. Now we have been asked to find the equation of the straight line in terms of I and N. So our equation of a line we know is y equals mx plus c, and we have to turn that into terms of I and N. So if her income increases based upon the number of policies that she sells, the income is going to be dependent upon the number of policies that she sells. So the income is going to be where the y is, and our n is going to be where our x is. And C, because also you can just substitute, because this is the y-axis, which is vertically, and this is the x-axis, which is horizontally, so you can just substitute them, the corresponding values. And now we need to find M and C. So first I'm going to find C, because that's going to be the easier one to find. And we know C to be the y-intercept, so wherever it crosses the y or the vertical axis, and we can see that it would cross the y-axis here at 400. And so our C is going to equal $400. And now we just have to find the M. We know our M to be rise over run. So we're going to go and do that now. I'm going to do it in red. So I'm going to pick 600 as my first point and my second point to be 800. And so this is my run, and here will be my rise. So my rise is going to be from 600 to 800, which we know to be 200. And my run is going to be from 4 to 8. So that's going to be a value of 4. And so 200 over 4 gives us a value of 50. And so our M is going to equal 50. So now I can write my equation here. I, or income, is going to equal 50N plus 400. So when you look at this equation we just drew or wrote, the y-intercept is normally the fixed term or the base salary or whatever you get no matter what. So no matter what, we're going to get 400. That is fixed. Regardless on the number of policies we sell, even if we sell 0, we get 400 because that is our fixed value. So that is always going to be 400. And then, depending on how many policies we sell, we're going to get commission, which is extra money. So that is going to be the 50N. So for every policy, we're going to earn $50. And so the M is going to be the one that changes. So let's have a look at the next question. E. Use the equation to calculate the weekly income when Grace sells 3 new policies. So the income is going to equal 50 times 3, because that's how many policies she's selling, plus 400. So put that into your calculator. 50 times 3 plus 400 is going to equal 550. Then it says, question F, how much does Grace earn for each new policy? And so we talked about that before, but if policies are N and we have a look at our equation, the value next to N is how much each one will be. So she'll earn $50 for each new policy. And so here in the question above, if she sold 3 policies, she would earn 50 times 3. So just one policy would be $50. And so that's how you use linear models. They're just real life examples of the form y equals mx plus c. And so you just need to know how to read the number plane, and you just need to know that we don't have any negative values. So that's why we only use the first quadrant, and then you can just read off the model to find your y-intercept and your gradient to solve the real life problems.